Welcome to the next lesson in this chapter, where we are going to implement the idempotent consumers pattern for our outbox message handlers. In the previous lesson, we implemented the outbox pattern, which guarantees at least once delivery for the outbox messages in our system. But this brings up the question, what happens if we want to retry publishing an outbox message in case of a failure, for example, and what are we going to do about handling duplicates, or in other words, about handling the same outbox message twice? First, let's introduce the concept of idempotency, which is the ability of a system to produce the same outcome even if the same event or message is received more than once. You can also think of idempotency as preventing the side effect of processing a particular message from occurring more than once. An example of this would be publishing the user-registered integration event. We don't want to publish this more than once, as it could cause unexpected behavior in the other modules inside of our system. So this is where the idempotent consumers pattern comes in, and in general we have two ways of how we can achieve idempotency in our event handlers. The first approach is implementing your consumers so that they are idempotent by design. So in case of a duplicate message or event coming in, your consumer wouldn't produce any additional side effects in the system. For example, let's say that we are processing the user-registered integration event inside of the attendance module, which is going to send a command within that module to duplicate the user data into an attendee. Now, if a duplicate message were to come in and we send the same command, what do you think would happen? Well, because we have a primary key on the attendees table inside of the database, we will not be able to insert the same primary key more than once. So in this case, we could handle the duplicate message, which would fail because of a duplicate primary key, and this will cause an exception, keeping our system safe from duplicating the side effects. However, it doesn't gracefully process a duplicate message, which brings us to the second approach. And the second approach for implementing idempotency is explicitly deduplicating incoming messages. And this is the approach that I'm going to show you inside of this lesson, where we are going to implement our idempotent consumers for the outbox message handlers. To help you understand why this is useful when we are publishing a domain event, just think of a scenario where we have more than one event handler for the same domain event. If we publish this using Mediator, it's going to invoke each of the event handlers one by one, and let's say one of those event handlers throws an exception. We would immediately short-circuit the execution, and we could end up in a state where some of the message handlers didn't execute at all, and of course the one handler that threw the exception also didn't execute successfully. So let's say that we attempt to retry the publish of this domain event. In that case, we could end up running some of the event handlers more than once in order to compensate for a failure, and this isn't what we want. What we really want is to only run the event handlers that didn't execute before when we publish the domain event more than once. So in this example, the first two event handlers wouldn't execute because they already handled this domain event, and we would only handle it for the third event handler that ran into some exception. So now let's jump into the code, and I'm going to show you how we can implement this. Inside of the common application project, we have our custom iDomain event handler interface, and we are implementing this using Mediator. So this interface implements iNotification handler, which allows us to publish our domain events using Mediator. If we want to implement explicit deduplication of our domain events, we would need to decorate the domain event handler with some generic logic that is going to check the current domain event based on its identifier, check in some table in the database if we have already processed this domain event, and only then allow the original domain event handler to execute, and after it successfully executes, we are going to write a record into the database stating that this domain event handler has processed the given domain event instance. Now, if we want to implement a decorator, we have to reach for some external NuGet package that's going to give us this functionality, and there is an excellent NuGet package called Scruder that allows us to easily implement decorators using dependency injection. Unfortunately, Scruder will not work correctly with Mediator because of the way that Mediator registers the notification handlers with dependency injection. So unfortunately, we will have to drop support for Mediator entirely when it comes to our domain events and implement our own system for publishing and handling domain events. So let's start by updating the iDomain event handler and remove the dependency on Mediator. This means that we will have to define our custom method on this interface to handle a given domain event. So let's make a handle method with a domain event argument. And let's also give it a cancellation token that could have a default value. I'm also going to create a non-generic version of this interface. So let's call it iDomainEventHandler. And it's going to have the same handle method, accepting an iDomainEvent instance instead of a generic one, and also accepting a cancellation token with a default value. To make our implementation easier, I'm going to create a default implementation of the domain event handler interface. So let's call this the domain event handler. This is going to be a generic implementation, and let's implement the iDomain event handler with a generic argument. We also have to add a generic constraint that the tDomain event argument is an iDomain event implementation, and then we can implement the missing members of this interface. What I also want to do is to have the generic iDomain event handler implement the non-generic one as well. So let's also implement that in the domain event handler. And then I'm going to make the handle method with a generic domain event abstract, and we're going to implement this in our concrete handlers, and the non-generic one is just going to call the generic method, cast the domain event argument into the concrete domain event instance, and it can also pass in the cancellation token. Because our methods are asynchronous, we have to return the result of the handle method. Now I'm going to move the domain event handler implementation into its own file, and now we will need to update all of the implementations of the iDomain event handler interface. Let me go to the user registered domain event handler and show you what this will look like. We are going to replace the generic interface implementation with a domain event handler implementation. So now I'm implementing the abstract base class, and I'm going to make this an override of the handle method. I will also have to update the cancellation token argument to accept a default value, and this will fix any compile errors in my domain event handler, and we can continue with our implementation. Unfortunately, I have a bunch of domain event handlers inside of the solution, so I will go ahead and update all of them behind the scenes, and then we are going to continue our implementation. With all of the domain event handlers updated, to now implement the abstract domain event handler class, we can continue with our implementation. One thing you could consider doing is updating your architecture tests that were referencing the iDomain event handler interface to also target any types that inherit from the generic domain event handler. So it would be a good idea to update all of the architecture tests, which I'm also going to do. And with our architecture tests updated, we can move on to solving the next problem that we have, and that is actually registering our domain event handlers. Up until now, we were using Mediator to achieve this, but now that we have our custom implementation, we have to do this manually. So I'm going to add a code snippet inside of the users module. Of course, you will be able to grab this code snippet from right under this video, and let me walk you through what we have inside. I introduced the add domain event handlers method, which is an extension method on the iService collection interface. And what I'm doing here is taking the application assembly, getting all of the types from this assembly, and then filtering to find the ones that I can assign to the iDomain event handler interface. Notice that I'm using the non-generic iDomain event handler, which makes my life a bit easier. And this is going to give me back a list of types representing my concrete domain event handlers. Now I'm going to just loop through all of these types and register them as scoped services. So let's call this method from the users module. Let's say at the start of the method, I'm going to say add domain event handlers. And now we have to update all of the other modules in our system to also register their respective domain event handlers. Now that I'm registering the domain event handlers from all of my modules, the next problem I need to solve is how we will be calling the actual handlers. If we go into one of the process outbox job implementations, for example, for the users module, and take a look at how we are publishing the domain events right now, you can see that this is using Mediator. But since we aren't using Mediator anymore, we have to move this to the new implementation. So first I'm going to introduce a little helper that's going to allow me to resolve the respective handlers for a given domain event instance. And I'm going to add this helper inside of my common project. In the Outbox folder, I'm going to introduce a new type called Domain Event Handlers Factory. You can also find this file under this video, and let me walk you through what we are doing inside. First of all, notice that this is a static type, and we have one method inside called getHandlers. This is going to accept a specific type, which is actually going to be our domain event type, and we're also going to take in a service provider. This is going to be a scoped service provider so that we can get back a scoped instance of the iDomain event handler interface. We will also take in an assembly which we will scan for implementations of the respective interface. And then here is what we are doing inside of the implementation of this method. I have a concurrent dictionary with a string key and an array of types as the value, and I'm forming the key from the assembly name and the type name for the specific domain event. I'm doing this to ensure uniqueness across the different assemblies that we have in our modules. The get or add method on a concurrent dictionary accepts a key and the factory that is going to invoke if it doesn't find a value for a given key. And what I'm doing in the factory is using the assembly that was passed in to get the types from this assembly and then find any types that can be assigned to the iDomain event handler interface. However, I have to be more specific this time and create a generic type for my specific domain event so that I only get the handlers for the concrete type of the domain event. Once I have these types, I'm going to return them from my dictionary, and this is only going to execute once across our requests, and because this is a concurrent dictionary, we will be able to share this result in the future. The next thing I need to do is to go through each of my domain event handler concrete types and resolve them from dependency injection using the service provider that was passed in. Once I have the domain event handler, I can safely cast it to an iDomain event handler, which is our non-generic implementation, and remember that we defined an abstract type, the domain event handler, that implements both of these interfaces. So we are going to return a collection of iDomain event handlers, and now we can use this from the process outbox job. So let me show you what that will look like. I'm going to get rid of the publisher as well as the call to publish the domain event, and I'm going to use the domain events handler factory, and let's call the get handlers method. The first argument is going to be the type of our domain event. Then I need to pass in a scoped service provider, and finally I need to pass in the assembly where my event handlers are going to live, and this is going to be the application assembly of the respective module. If we add a variable to hold the result of this method, we're going to get back a collection of domain event handlers, and now I can do a for each loop and call the individual domain event handlers one by one. So I can say await domain event handler handle, and I can pass in my domain event instance, and this is going to execute the respective handler. So up until this point, we were just replacing the existing way of how we were publishing domain events with our custom implementation, and now this is going to allow us to easily introduce decorators for the domain event handler interface. So let me close down all of the files that I have in place, and let's start our implementation of the idempotent consumers pattern for our outbox. And I'm going to introduce two additional types into the outbox folder. The first one is going to be an outbox message consumer. This is how we are going to check if we have processed a given outbox message for the respective handler. The outbox message ID is going to point to the outbox messages table, and the name property is going to be